I keep a close watch on this heart of mine. I keep my eyes wide open all the time. I keep the ends out for the tie that binds, because you're mine. I walk the line. A little bit of Johnny Cash for you this afternoon. Give it up for Mr. Johnny Cash, the man in black. Today we're talking about density curves and continuous random variables. And iPad, can you stop making those? Just stop drawing. You're distracting the students. They're trying to be serious here. Stop. Yeah, really funny. I know I'm really bad at drawing. Insert drawing here. What a joker you are, iPad. It's time to get serious. Oh, okay. So, what is a continuous variable? So first of all, an example of a continuous variable would be height. The reason height is a continuous variable is because we need to talk about ranges of height. For example, what is the probability that you randomly select someone who is exactly 6 feet tall? Now, if you look closely enough, no one can be exactly 6 feet tall. They're got to be a little bit higher or a little bit lower. Instead, when we say someone's 6 feet tall, they're within this range that's close to 6 feet tall. So the key idea in continuous variables is we can't have an exact probability. For example, in a continuous random variable, the probability that x equals 2 cannot occur. That is the critical difference between a continuous random variable and a discrete random variable. For example, if I am randomly selecting a card out of a deck, the probability of drawing an ace is 4 out of 52. That is discrete. But a continuous variable, for example, time, the probability that a randomly selected person can run exactly 6-minute miles is 0, because there's some range between 5:59 and 6:01 that we decide we will round to a 6-minute mile. So that is the critical difference we need to understand. So generally, when we're talking about a continuous random variable, we use a density curve. And this is the beginning of what a density curve looks like. Notice on the left we have a probability density function. If you don't understand what that means, don't worry about it. Just letting you know what it is called. And the x is always our variable of interest, and the height is always the probability. Now remember, a specific x value for a continuous random variable cannot have a probability, or it does have a probability of 0. So we label x values, and we label probabilities associated with it. And let's suppose this is our density curve. Notice the entire area of this curve is 1, because every single square here, let's take a look at this square. That square has an area of 0.1. Well, how do we know? Because it has a width of 1 and a height of 1. That is a rectangle with area equals 0.1. Now, if we count up all of these boxes, we have an entire area of 1. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, they all have, we have 10 squares, all with an area of 0.1. So the entire area is 1 under the curve. So let us take a look at some ideas here, and let's calculate some probabilities. Now, using a density curve is really, really easy. You just have to remember that the probability of getting an exact value is 0. So, what is the probability that we have x equaling 4? What do you think the answer is there? Pause your video and think about it. Assuming you're thinking about it and you've got the answer, that's 0. I just pretty much said that answer to you a couple seconds ago. Now, what's the probability that we have a value between 3 less than x less than 4? What would that equal to? Pause your video and think about it. Alright, assuming you've paused your video. What we do is we look at the area between 3 and 4. So what's that area? We have 0.1, we've got 0.2, and we've got 0.3. So the entire probability of being between 3 and 4 is 0.3. Isn't this amazing? Aren't you just totally and utterly amazed by this awesomeness? Let's get rid of that if we can. A little bit of eraser work. Oh no! My eraser is over erasing. This is a problem. You need to get your eraser checked, ladies and gentlemen, if your eraser is over erasing. Alright, let's think of another problem. What could we do here? How about the probability that x is greater than or equal to 3? Pause your video and think about it. Assuming that you've thought about it and you've put your brain to good work, let's take a look at the answer. Man, I'm having fun making these videos today. You know, I love you guys. Just want to let you know, care about you. Whatever you need me to do in your life, I will be there for you. Probably, maybe. Like, if you need me to hide a body, I can guarantee you I will not help you with that. So don't do anything crazy. So now we look at all the x values greater than 3 and we count up that area. 2, 3, 4, 5. So this gives us a probability of 0.5. That is this whole area under the curve because we go to the right of the 3 value. Ta-da! Dum-ba-da-da, dum-ba-da-da. That has 5 squares. Each square is an area of 0.1. So we're all good. What else could we ask? How about the probability that x is between 0 and 5. Now, one thing to notice is this equals sign under the greater than or equals to doesn't matter because the probability that x equals a value is 0. So if you're between 0 and 5, that is the entire distribution, ladies and gentlemen. That's the whole thing. So that area is 1. Booyah. So the probability is 1. The key thing is to realize the area is the probability. Once you've got that, you understand density curves. Let's see. If I tell you, let's take a look at a new problem. 1 second here. Let me pause my recording. All right, ladies and gentlemen, real serious problem here. Let's say the probability, that's a stupid question. Let's change that. The probability x greater than 2 is 0.05. Let's say the probability that you have an x value greater than 2 is 0.05. What is the probability that x is less than 2? Well, the entire area under the curve is 1. Think about that. Pause your video. All right, you're back. What's the probability that x is less than 2? Ding, ding, ding. It's 0.95. Because if this area is 0.05 to the right, that means the area to the left, I failed arrow making class in high school. That's probably why I can't make arrows. That's too bad. That means that has to be 0.95 because the entire area under the curve has to be 1 because that is I'm getting so excited I can't talk. Because that's the definition of a density curve. Well, now that I've officially made a fool out of myself, and I need to make one more video, let's call this a day, shall we? It is a day. Good night. Well, then it would be good night. Good day, rather. Good day to you.